All right, we are in week 13 now, I believe, getting close, 2 weeks to go. One more week of class and then it's finals. And what we're going to do today is go over the problem set. Some of the folks have been struggling a little bit with problem sets, so we're going to take a look, start out with the basics, problem set 1, and kind of show you how to set it up in Excel. Excel is definitely your friend here in doing these problems, and the sooner you get started with Excel, the happier you're going to be in this program, because by the time you get to Energy 214, which is semester 4, that is a very intensive, very brutal class. Figuring out really complicated problems like these costing problems, and you don't want to be struggling with the basics of Excel. So the more familiar you get with it now, the happier you're going to be later on, and the easier it's just going to make life for you in general. So we'll take a look at the problem set 1, and we're going to set it up in an Excel document. And of course, we'll start out with the very first one. Let's make this problem. We'll do problem 1. And we probably should, let's read it first. Problem 1. Express the amount of energy the average human consumes metabolically per day in calories, little calories, big calories, joules, megajoules, BTUs, therms, and kilowatt hours, and show our work. So we probably kind of want to have a data table on this. You always want to set up your data. If it's something we know that if we're going to look at question number 2, express the amount of energy the average human consumes technologically, hey, look, we're looking at calories again, we're looking at joules, megajoules, so we kind of want to set up a data table over here that we can reference. Rather than have to type these in each time, I can just reference a cell, and then if anything changes, obviously our values for joules or megajoules or whatever, those conversions are going to stay the same. But say I want to change the values of what the average human consumes because something changes and we start using more technology. There's some major change that worldwide that number is going to go up. I want to be able to just plug that number in rather than have to go through and change every single formula within there. I can just change one block and be done. So we need to do, we're going to set up our tables over here off to the side where we can work with them, and we're going to do our conversions first. So what all do we need to convert here?
Little calories to big calories, joules to megajoules, BTUs to therms.
Yep. So let's do our calories. We know 1,000 little calories equals a big calorie, right?
And that's why it's called a kilocalorie, so you automatically know that it's 1,000 to 1 ratio.
Yep. Equals 1 big calorie. Okay. What's another conversion we're going to want on there? I need joules to BTUs. So I know 1,055 joules per BTU. I need megajoules to kilowatt hours, and I know 3.6
3.6
megajoules per kilowatt hour. Let's see. How many joules are in a megajoule? So 1, 2, 3, 4, 5, 6. Joules per megajoule. And then I want, what's that?
You also need to convert calories to joules.
Yep.
Which is 4.2 joules per calorie.
Okay, let's do that up here with the joules and calories. Oops. Come on. This little mouse is a pain. This laptop's a pain, one or the other. This thing's grinding trying to keep up.
And the computer recognizes for as far as formulas that when you're just putting BTU, that it's just one.
What, say
The
again?
unit is one. The computer recognizes where you put like 1,055 joules per BTU. It recognizes that just BTU in itself is one.
That joules per BTU is purely a label. It's not gonna.
Oh, there's not going to be a conversion. then?
No, what I'll do, I'll use the number 1,055, and then I'll add later on wherever it is in my wherever that calculation is. That's where I'll add that in there.
Okay. I didn't know if you're going to be able to put, if it would work, that you're going to be able to put in your formula bar that you have, 42 BTUs.
No, your
that
formula
represent
bar.
cell.
Your formula bar will only recognize numbers and symbols, and none of these are. It just sees them as letters. It doesn't see them as anything else. So it was 4.2
Joules per calorie. Low calorie.
joules per calorie. Okay. We're going to need joules to exajoules. And now we're getting to the point where we need to start using notation. E was 18 zeros.
18, right?
Yep. Let's see, we need to know BTUs to therms. .00 E. Let's see what else we need. We've already got joules to calorie. How many days in a year? Need our hours per day. So it takes a little while to set all this stuff up, but once you do, you'll see it makes everything else so much easier. We'll want watts to horsepower. And that's 746. And we want watts per kilowatt hour. or watts per kilowatt, I'm sorry. All right, so now that we have all those numbers in there, we can actually modify this one a little bit. Get rid of that other table. All right, so we're also given some data on this problem. We know that 2,500 is the big calories per day is human metabolic consumption. We know that 500 exajoules per year is a human technological consumption, and we know what the human population is, which is 7.00 E plus, why is that not typing in?
Where'd you get the 500 exajoules per year from? Is that in the book somewhere?
It was either in the book or Brad gave us. It doesn't show.
I don't know. I forget what I got, but I used 200 megajoules per person per day.
Okay. And that's the advantage of having it on the Excel, is it's easy enough to change it. But whatever your value is, that's fine because it'll, yep. Okay. E plus. Is plus. When you're putting it in here, it's a plus. Because of the E, it's telling you that's an exponent. So if you do a times, it would screw up your calculation. Okay, so that's how many people we have. So if I want to find, tell you what, let's make some room here. So the first thing I want to find out is how many little calories. I want to find out how many big calories. I want to figure out how many joules. I want to find out how many megajoules. How many BTU? That won't work that way. I knew I should have had this set up first. Oh well. It's good for you guys to see me struggle with it because it's. You'll see it even if. Yeah, no matter how much of this crap you've done, is still. It's real. Oh, I know. And it's
The worst part when he does it is he won't type things out like you are. He reads everything.
Everything.
right. So later on,
Abbreviations you've never heard.
when you're looking at it, you're like, what did that mean?
The example for summary 3 that was on Google Shell was Greek.
Oh, I found it.
Everything was just one letter. Everything was labeled with one letter. And you're like,
Oh, I feel your pain. Trust me. I've been there, done that. And the pain kind of like never goes away. That's my problem. Is that pain, not only is it real, it's like freaking permanent.
It's not what we're living in here.
it may fluctuate in severity, but it's always there.
Okay, so since I know these numbers now, let's go right down the list. So I want to know the amount of energy that the average human consumes metabolically. We know from our information over here that big calories is 2,500 big calories per day. So I can just make this a simple equation, right, with my conversions. Oops. So equal sign, that tells Excel it's going to be an equation. I'm already given 2,500 calories a day, so I know it's that one times that one, right? Because there's 1,000 per. Oops.
Go back and click J4 again.
Yeah. And we'll clean it all up later with commas and everything nicely, but that looks about right, right? 2.5 million baby calories. We already know this one here is a given, that I can just put that equals this, because I already know that number, 2,500. So joules, that's going to be an equation, right? How do I figure out my joules? I've got a calorie to,
Joule conversion,
yep,
multiply the 2.5 million times 4.2.
this one here times 4.2.
D4.
That looks about right. Is that where I can see everything? Okay, so megajoules, another conversion. That's just, sorry?
You just divide by a million.
Yeah, I could do that. I could do this number divided by a million. Or, let me see, what am I looking for? I'm getting sidetracked here. I'm looking for that number in megajoules.
You can just get rid of 5 zeros.
Let's see. What numbers do I have over here that are worthwhile or worthwhile? Okay, that is my million. So I do want this number divided by that number. I knew I had a conversion there somewhere. 10.5 BTUs. Another equation. We know how many joules there are in a BTU. So it would be this number divided by that number. So I'll convert it to therms. So if we know it's this many BTUs, that number divided by that number, and kilowatt hours We know what our megajoule conversion is. So if it's 10.5 megajoules divided by 3.6, 2.91 kilowatt hours. So that is problem number one done just like that. So you can see the ease of using this comparatively, although it takes longer to set it up. Otherwise, you got to do all these calculations on a scrap piece of paper and go through this. So technologically, we use 500 exajoules a year, and that's all of humanity. So we know what exajoules are. So how would I come up with this formula? Throw some ideas at me. What would you do with this to make it?
First, you need to keep your daily technological consumption in years, right? If you're looking for
Yep.
daily technological consumption, you can divide your 500.
Yep. So, and that's just going to give it to me in exajoules still.
Per day.
Right, exajoules per day. So let's do a conversion over here of exajoules per day. And that's just going to be that number divided by 365 days in a year. So that's how many exajoules a day I'm using. So now to convert that to calories, what would be my equation?
You've got calorie to joules, so shouldn't you break that down to joules? So you can use your simple conversion.
Say that one more time.
So when you want to break your 1.37 exajoules per day down to joules, so you can do your easier conversion from calories to joules?
Could do that. Should I do that in the equation, or do I need that as a? Do you think I should do that as a separate, another given over here? As a whole, what would you guys do? It's your choice. I can do it in the equation, or I can do it. So let's convert this to joules. Screwy. Joules per day. And that's going to be what's my equation look like for that?
And use your exajoules from above it.
Can you use which one? Sorry?
Your exajoules per day.
Yep. That number right there. Okay. So now I have how many joules per day it is. Oh, that's why. I was like, why is that thing? So
Copy that formula under your joules.
copy that formula to where?
In your table under joules.
Yeah. So that was just going to be a, oops, for 100 joules equals that number right there. So now all I need to do is start converting. So in joules, it's pretty easy. We know how many joules are in a calorie. So that will just be this number times 4.2. big calories is just going to be that number divided by that number. Megajoules is going to be that number divided by I don't know how many BTUs that is. So it'll be joules divided by that number. Therms will be that number divided by that number. And it'll be that number divided by that number. There's problem number 2 done, just that quick. So is it making sense? Are you guys kind of seeing where it's coming from? All right, so I'm not really going to screw around too much more with problem set 1 because it's just going to be a continuation of this table using the same data over and over again to figure out all these different things. I'd prefer if we can look at problem set 2. We'll get rolling on that. We'll just make that another sheet. And let me pull that up on here. So we have it for reference. Oh, is my computer is that slow or the internet? Kind of brutal. It doesn't like the snow either. I looked out the window and I thought, okay, well, that's kind of sweet. I don't mind this. And then I took off driving and got over by the university, and right there on the bridge over the river, there was a Jeep Cherokee just mangled. Had spun out and spun back around and hit the curb, and like the back wheels folded over underneath it. Like, oops.
That's must have been what Holly was talking about. That's from Van Buren.
Yeah, Van Buren. Yeah, they were coming from the university, and I think they were coming up to merge and got on the gas. And that bridge was a sheet of ice. You could see it was, and you could see all their skid marks. And they spun around, and where that back wheel hit the curb and just folded it under. Okay, so we're going to do the same thing. Let's see. Show all calculations, terms, and units. And there is a way to do this that I'll show you in a minute on Excel. You may not have to do it here. Well, you do need to do it on this problem set. But what you do is you're basically making 2 different copies. If you send me a pure Excel document, it's okay. I can look at the formulas and see the formula in the block. I don't care. You have the number there. That's all I want to see is the number. And if I want to see how you got that, I can click on it and it'll show me what your calculation was. There's also a way to do that. Save this as a PDF so that it will show calculations instead of the numbers, or show your formulas instead of the numbers. So that's another optional way to do it. Is if a lot of times that's the case in a lot of these classes, we're more worried about what formula did you use rather than what number, because it all depends on rounding, and if you pulling data from all these different places, everybody's going to come up with different answers because they're going to round differently. So it's easier for me to see that, yes, you used the right formula, so therefore your answer is correct, even if it doesn't exactly match the person sitting next to you. Okay, so table 5.1 of our text, we're looking at coal. What is that? Coal reserves and production. At our current usage and production ratios, how many years of coal left do we have left? And if we were using China's values, how many years do we have left? And at our use with China's reserves, how many years? So it looks like we're looking for let's see. So number 1. We've got USA and we've got China. So according to table 5.1, our reserve, and this is going to be in years, is 238. I'm not actually looking at that table. Does that match? Is anybody looking at that table?
1,000 MT, but the RP ratio / years is 245.
So the reserve is 238,000 megatons.
Okay.
Or per. Yeah, see, I wasn't sure how to, it just says reserves / 1,000 megatons, but then it gives you a number of 238 in the graph. Does that mean it's 238,000 megatons?
Let me pull up the table. 5.1.
Page 163.
Perfect. Thank you. Yeah, that's the 238 should be the reserves of metric tons. The ratio of years that number should be 245, not 238. Okay.
The 245 is what we're trying to figure out, and we know what it is because of the table, but we're trying to do the math problem to figure out how many years are left.
Let me see.
Yeah.
So you take USA reserves, multiply it by
Our usage.
and then divide it by
Yep. Yep, you're right. So it is 238. So this computer could not be any slower. It's locked up here. There we go. I know Brad knows some fancy. Um, 238, and China's is 115, and then production. Is that what we're looking at? Yeah. And how much is the U.S.?
245.
No, annual production. So 973.
Oh, 973.
China's is 3,050.
3,000 what? 3050. Okay. So that's our data table. Now I want to find let's see, U.S. remaining. I'm going to find U.S. with China production and U.S. with China reserves. Okay, somebody was spitting out the formula earlier of how are we going to find this for the USA.
Reserves divided by production.
Okay. So for us, it's as simple as we have this much reserve.
We have to multiply your reserve by 1,000.
Oh, yep. Times 1,000 divided by what our production is, 244.6 years. So we're going to do the same thing. We're going to do our reserve of this times 1,000 divided by China's production of 3,050, 78 years. And this one will be, what was the question?
China's reserve with that U.S. production rate.
Okay, China's reserve times 1,000 divided by our production rate.
It
100
works out that way, but you actually multiply the production by 1,000, not the
Oh, did I? Let's see, I wanted China's reserve of 115 times 1,000 divided by our production. So yeah, that's right. Okay. So there's problem number one. Pretty straightforward, right? Problem number two.
Now, are you worried about having the reserves and the production values, having units attached labeled somewhere?
Yeah, I would probably put in another, probably just expand this column here so that you can put that 1,000 metric tons.
10 tons in it.
Yep. And the layout's going to vary however you like to do it. It kind of doesn't matter. whatever your personal preference is. Okay, so number 2, looks like we're figuring out efficiency. Wood-fired boiler produces steam delivered to a turbine generator for electrical generation. Steam temperature of the boiler is 900 degrees Fahrenheit. Temperature of the cooled condensate coming back is 100 degrees Fahrenheit. What is the theoretical ideal Carnot efficiency of the turbine? Okay, first thing we'll do is make our little table of data. What do we know? And then what do we need to know in addition? Information that we are given is the temperature in, and that was 900.
Doesn't matter if we use Fahrenheit.
Well, we're going to need to address that. Very good point. But for right now, we need to use the numbers that we're given, because if I want to change this later, I would rather have the conversion be later on in the process, so I can change a basic number. Because if somebody's giving me the basic numbers now in Fahrenheit, odds are if there's a replacement number, they're like, oh, never mind, it's only 875. I'd have to change all my formulas if I do it in Kelvin here. So it's easier to do that conversion.
Why is that the end product is different from the original Fahrenheit?
Yes, absolutely, it is. So we do have to do that conversion. And that's, again, where the labeling becomes important. And how do we find Kelvin? We know, actually, let's put that in there as a known. Kelvin is, how do we figure temperature? It's 273 is the baseline, right? So if I want to convert those numbers to Kelvin, how do I do that?
Take the Fahrenheit plus
Track.
I use the formula of
Take your Fahrenheit 900 plus 459.67, and then you divide that by 1.2.
What is my where to get 459.67?
I think I grabbed that off the internet somewhere.
Well, let's
I
see.
didn't find anything in the book.
Yeah, this thing doesn't show.
I'm not even the substation. I Googled.
Yeah, that's going to be our easiest.
Yeah, the Celsius, you just subtract 32 and then divide by 1.8. And then, I mean, the Kelvin is basically the same thing, only you're not subtracting the 32, you're adding the 459.67.
So you did a conversion for 900. For the 900 degrees?
900 and 100.
Okay. What I'm hoping that we can find here is a
1 degree Fahrenheit equals
right.
what Kelvin.
Shit. Fahrenheit to
Yeah, that's the formula.
I was hoping there was a number. but there's not. Okay.
Well, it's on that chart, right? If you go to,
Yeah, if you go far enough.
if you add 0, it gives you the 200 Kelvin, right? At 0 degrees. Yeah, 755.4 and 310.9.
255 plus 900, right?
Or, no, it's 100. You're using your 100, so it's 310.
So whatever your temperature is in Fahrenheit plus 459.67 times 5/9. So that's our actual formula. Let's go ahead and copy that. And we'll put that into our, I'm going to put it off to the side here so I can see it. And let's actually make that right. Let's make this Kelvin. Computer's locked up again.
When you're trying to type on the keyboard, you need to type on the laptop, right?
Good call. Jeez, too much junk in front of me. Okay, so Kelvin. So this formula is going to be whatever this number is plus, oops. And you know what, I'm going to put that 459 down here so I can reference it. 459.67. $459.67. So this one will be that number plus this.
Times 5 divided by 9.
And let me do this because I'm going to screw myself up if I don't put my parentheses in there. What are my... No, leave me alone.
Starting parentheses.
Yeah, I know. That's what I'm trying to get to, and it's trying to help me before I can get there. Times 5 divided by 9. Okay, so it gives us the right number. Good.
Can you go back up so we can see that formula?
Yeah. So it's our 900 degrees cell plus that 459.67, and then both of the whatever the sum of that is times 5/9. It's basically this formula over here off to the right, only it's written in Excel. And you'll see we're going to do the same thing for the next one. So it's going to be this 100, oops, parentheses, this 100 plus this number here, close your parentheses, times 5 divided by 9. There's our temperature out in Kelvin. Okay. So now we have to figure out our Carnot's efficiency, which is very simple formula, right? What is it?
T1 minus T2 over T1.
So our 900 degrees, only now we're going to use this number. So our actual answer is this number minus this number. And once again, we need parentheses. God, leave me alone. Divided by this number again, correct?
You multiply by 100, so you can just format it as a percent.
Yep. And I don't like adding, I don't like multiplying or dividing by 100. I prefer to set up the block, format it. I think it's personal preference. I'm pretty sure Brad prefers the I'm pretty sure he prefers the dividing or multiplying by 100. So that was pretty straightforward, right? Does that make sense to everybody? I don't want to lose anybody.
Now, do you want us to show the Carnot equation, like we did the conversion equation?
Yeah, and if you want to do that, you're talking about show this equation instead of the percentage, you mean?
Well, I mean, we did that, but, you said you want givens, and you need, essentially, that's a given that's the efficiency equation. So you want,
If you wanted to,
know where we got that?
yeah, and that's not bad. That we could do, over here along with that other equation we use for Kelvin. You can do Carnot is temp. Does this have? Nope. That's weird. Oh, I'm on the wrong. Temp 1 minus temp 2 divided by temp 1. If you want to do something like that next to it, that's fine.
Yeah, I mean, just the instructions say that everything needs to be spelled out.
Yeah, and like I said, if you're submitting it in an Excel, I'm not worried about it because I can click on this and see, yeah, that's the right answer, but how'd you get there? Oh, look, it's Carnot's theory.
Okay.
So I can see, as long as you send it in an Excel document. If you send it in a Word document or a PDF, then yes, I need to see both. But if you're just sending it to me as an Excel, I can click on it and see which one it's going to be. So,
Isn't there an option to turn your formulas on and then
yes.
you could say the second sheet is
Yeah,
formula
you could copy sheet 2 that you have now and put it on sheet 3, and then you can just set it to show formulas.
Yeah.
So you can
Yep,
have
exactly.
Essentially, this is the same thing on 2 sheets, but one showing your answers, one
I'm
showing
showing
the
formula.
formulas.
I remember doing that.
Um,
I don't remember the exact way to do that. It was like 2 months ago. Show formulas right down the right.
Oops.
Formula auditing.
Shit.
So I think you're back button. Formula auditing box all the way to the top, or directly above where your cursor is. Okay, show formulas.
Yep. Yep, you can do that. And what I do, like for 214, you'll save this as a PDF, and then probably won't even mess with the other, with the correct answers. And then save this as a PDF, and then you submit the 2 PDFs side by side. So one has answer numbers, the other one has formulas. So you can see both. All right, what else do we have? All right, do we want to look at question number 3? You guys got other questions for
I'd
me?
rather move on to 4.
Ready to move on to 4?
Yeah.
Okay.
4 and 5 were kind of confusing.
All right, so number 4, coal strip generating facility produces over 2,000 megawatts of electricity at a capacity, burning coal to produce electricity. Soon plant produces at 50% capacity for one day. So 1,000 megawatts, right? How much electricity in megawatts or megawatt hours per day? Should be pretty straightforward. How much coal are we going to use to do that? So we need the heat value for coal.
That gives it to you, correct?
Yep, 24 gigajoules per ton. And we assume the efficiency is 30%. All right, that's good. That's fun. Sweet. I'm not as bad as Brad. It's not that much fun, but I won't do it in my off time. But since they're paying me to sit here, I'll do it right now. How's that? I'm sure Brad would do this on Thanksgiving Day while his family's eating turkey.
Yeah, I'm sure he reads papers and then double checks people's numbers that they give.
Yeah, exactly. I learned my lesson. I did that with a textbook, and I spent like 4 hours because the textbook was wrong, trying to make sure I was right and they were wrong. Okay, so some of our given stuff that we know. So what's our given information? We know it's 2,000.
Megawatt capacity.
Capacity. We were just talking about you.
Yours must have been better, huh?
Yeah, we were just talking about you. How on Thanksgiving everybody else going to be eating turkey, and you're going to be sitting over there checking people's math.
On the sport.
That's right.
The sport of energy conversion.
We know there's 24 hours in a day. We know there's at some point we're going to figure out 0.5 is operating at half capacity. We know 24, what was that, megajoules per gigajoules per ton? Okay. And we know the coal to electrical efficiency is 30%. All right, so given that data, remember what we're looking for again.
First, you just wants megawatt hours per day.
Okay. So,
First, we need to figure out what is around that. It's not capacity. So you can multiply your 2,000 by your half capacity.
well, the first question is, what is it doing at capacity, right? Assuming it's, oh, gotcha. Didn't assume, is it 50%? So how much is per day? Good call. So let's see, we know its capacity is 2,000. Oops. Yeah, I can't have the megawatts on there. Good call.
It's okay, leave it for now, we'll just correct it after we get the error.
Okay. So I know I can do that times, oops,
.5.
my 0.5. Okay. and it's gonna run for 24 hours, right? So we'll multiply it out times that. And that should give us our, okay, now it doesn't like, so 24,000 megawatts.
Yeah, 24,000 megawatt hours.
Oh yeah, megawatt hours.
Guys, this kind of underscores that whenever you solve these, I mean, you're really solving three problems at the same time. I mean, you've got the number, you know, your 2,000, your 24, your 25. You've got your power of 10, kilo, mega, giga, what have you, and then your units. So there's, you know, 3 ways to screw up each number, and then if you got 3 numbers, there's 9 ways to or at least, you know, more than that way to screw it up. So, anyways, but again, the way Tim's doing it, just kind of one step at a time, is the right way to, you know, chew it off one bite at a time.
Okay. So what do we want to find next?
Find times per day.
Okay, yeah, Brad printed this, but he didn't give me the microscope
Oh,
to use, so I'm like, eh. Let's see. How much coal is burned?
Probably wrote on the Thanksgiving napkin, huh?
Yeah.
Yeah. All right, so we know this is going to be an equation. Where do we start at with this? What would be a good starting point? Do we want to do it all in one big equation? We want to break it down into a couple smaller equations and find a couple values and then combine those values to get this? What would be your preference?
Convert your megawatts to megajoules.
Okay. So how am I going to do that?
Just multiply your megawatts times 1 second. You need a megajoule, right? Because 1 watt per second is a joule.
So I'm going to need to know how many seconds there are in a day. So let's do 24 times 60 times 60. 86,460, and that's seconds per day. And we're going to end up using that. So, all right. What else do I need to know? You said it earlier. It's a watt per,
Yeah, 1 watt.
1 watt per second.
1 joule.
So you want to convert this number, 24,000, over to joules? Would that be?
No, you'd be converting 1,000 megawatts.
Yeah, 1,000, not per day, just your 1,000 megawatts per.
So that's capacity.
Right, and we're running at
multiply
half.
by your seconds to get
Yeah.
your megawatt hours or your megajoules per day.
Okay, so I'm looking at multiplying 1,000 because we're running at half capacity times
Your seconds per day.
times that. Oops, I didn't put my equal sign in first, sorry.
86,400,000.
So, that
Joules.
times that, and then times that. 86 million joules.
Megajoules per joules per day.
That's joules per day. Okay.
Megajoules per day.
That is megajoules? Okay.
gigajoules is 1 ton. So divide that by.
Should probably convert that to gigajoules, right? Okay. So how would I convert that to gigajoules? Oops. I've got the conversion up. Well, let's see. Sheet 1. That's exajoules.
You just add 3 more zeros.
Just times 19,500.
Take away 3 zeros.
Take away 3 zeros. Yep. Let's do this number divided by. That number.
Gig is more than mega.
Yeah, exactly. So the number's gonna, well,
It'll be smaller.
yeah. It's gonna be smaller in gigas.
You're taking
Gonna
away
make it
zeros and using
a larger.
Oh, yeah, never mind.
Okay, let's try this again. This, for some reason the formula is not working. J14. For some reason it does not like that one.
What are you trying to do?
For some reason it won't let me use this value. Oh, now it does. That divided by 1,000. That gets rid of those zeros.
gigajoules per day.
Okay. 24 gigajoules per ton. Yep. So that number divided by that number. So yep, that's so that's assuming perfect efficiency though. So now, so I can't really use that number because it's not accurate. How would I find out what 30% efficiency, how would I get my 30% efficiency?
Multiply it times 0.3, or divide it by 0.3.
Divide it by 0.3. There you go. So if I take that, oops, that number divided by that number, 12,000 tons of coal in a day.
I figured that out easier. You know, I multiplied it by 3.333 rather than just by.
Okay, yep. Which is smart. I mean, that's a good way to do it. But yeah, it's let's see, and then we'll label this one so we know that's at 100%, and this one is don't get frustrated with this stuff. It's really not difficult. It's more of figuring out a puzzle. Like I told you guys week 1 for word problems. This is more of figuring out a puzzle than it is doing really hard math. You can make it as hard as you want as far as the math goes. I mean, you could make it a lot harder than this, but really, all you're doing is putting together a puzzle. You've got a picture, which is your word question. You know, hey, how much coal are you going to use at 30% efficiency? And you've got all these little pieces. You just got to figure out how all these little pieces line up with each other. And this is awesome because you know on a level of scale how big or how small a number should be. So if you end up with something that doesn't look right, it's probably not. The cool part about using Excel is rather than spending 5 minutes with a calculator and punching all this crap in, it's very easy to change a variable and realize, where you were multiplying 3.333, oh, wait a minute, if I just divide or do something different, if the number's too big, probably you need to divide, or if the number's too small, maybe you need to multiply. So these are very useful to be able to play with. The Excel is awesome for being able to play with your formulas to get it'll look right and it'll feel right. If it doesn't look or feel right, then start playing with it and see what comes up. So does that help a little bit for your problem sets? Get you guys on the right track? 2 weeks till final, so try to get those things submitted. You want those out of the way so you're not, you already got summaries to deal with, you got finals to deal with. Try and get that crap out of the way as quick as you can. And I'll get in there and start grading them. I haven't done that, but I did go in there today and went on all the summaries and extended the date out until finals week. So you're not going to get some error saying you can't submit it or whatever. They're all extended out to finals week. But the sooner you get those in, the sooner you'll be able to get feedback from us, and the easier it's going to be for everybody. So
Do it before you eat the turkey, because it gets sleepy after.
there you go. There you go.
Happy to see you guys.
All that tryptophan.
Yep.
So I tried to resubmit my summary, but I neglected to put the citation